the height, f of x in feet. So we just know that f of x, which is y, is our height in feet. Of a ball thrown by a child is given by our function f of x equal to negative 1 over 16 x squared plus 4x plus 5, where x is our horizontal distance in feet. So x is our horizontal distance, again, in feet. Okay. Remember, horizontal is like left to right, and then our height is up and down. But it's the horizontal distance in feet from the point at which the ball is thrown. So we have a kid throwing a ball. We already found the equation that describes the height of the ball compared to how far away it is from the kid. We're asked what type of function is used to model the scenario. How do we know? When we look at our function, it is degree 2, or if you don't remember the word degree, you can say highest exponent. Is 2, it's in the form ax squared plus bx plus c, which is standard form. And both of these instances let us know that we have a quadratic function. So again, I worked backwards. I explained how I knew before I named it, but it is a quadratic function, not formula, my goodness. Function because of the highest exponent being 2. Part B, how high? High is y, that's height. So they're asking us to find y. How high, find y, is the ball when it leaves the child's hand? Remember, x is our horizontal distance, which is a fancy way of saying distance from the kid. Okay? So if the kid is just throwing it, what is the distance away from the kid? There is none. So x is going to be 0 when it leaves the child's hand. It hasn't gone anywhere yet. So they're asking us to find y when x is 0, which means we're going to take our function f, which is y, and we're going to plug in a 0 every time we see an x. So we're going to have negative 1 all over 16 times 0 squared plus 4 times 0 instead of 4x plus 5. And we find out that the ball is 5 feet high because this entered into your calculator gets you 5. So our answer, the ball is 5 feet high, which means that the kid is throwing it at 5 feet. Let's try part C. Part C says, what is the maximum height? So it's asking for the maximum y of the ball. And at what distance does the maximum height occur? So at which x? Okay. So with this, whenever they ask for maximum y value, they're talking about the y value of the vertex. So they're talking about K. Because remember, our vertex of any quadratic is in the form h comma k. And if they're asking where the maximum height occurs, at what distance, that means that we need the h coordinate of the vertex. Our equation is f of x equal to -1/16 x squared plus 4x plus 5. This is in standard form, the ax squared plus bx plus c. It's not in vertex form because we don't have parentheses quantity squared. To find our vertex, our h value is equal to -b all over 2a. In this case, the b is going to be 4, because that's in front of the x to the first, all over 2 times a, which is -1 all over 16. The opposite of 4 is -4. And in the bottom, we get -1 all over 8 when you take 2 times -1 over 16. When you do this in your calculator, you should get a positive 32. This is our x value, because it was our h, which means that our distance is 32 feet. So we found part of the answer. Distance is 32 feet, and we still need to find the height. So we need to find k. Remember, k is when you take your function and you plug in that h that you just found, which was 32. So now every time we see an x in our function, we're going to plug in a 32. So -1 over 16 times 32 squared plus 4 times 32 plus our 5. Plug this into the calculator and you wind up getting 69. This is our y value, which is our height. So we know that the height of the ball is 69 feet. If I needed to write my sentence to explain this, I would say the ball reaches a max height of 69 feet. At a distance of 32 feet. That's the fancy way of saying it.